Hi, this is the second video on the periodic table. For this video, you're going to want to have your guided notes and your periodic table that you colored last time, because you may want to add some stuff to it that you learned in this video. So last time we found out that the periodic table is divided into three parts: the metals, the nonmetals, and the metalloids. Now we're going to learn some common names of some family and groups. So we're talking about the vertical columns on the periodic table. All of the elements in a family, and it's also called a group, have very similar chemical properties. So let's go ahead and learn a few of these families. The first family I want you to learn is called the alkali metals. They are on the far left-hand side of the periodic table. Although hydrogen is placed above them, it is not an alkali metal. Hydrogen is a nonmetal. So the alkali metals are lithium and sodium, potassium, rubidium, cesium, and francium. So you need to know that this is the family known as the alkali metals. So let's talk about some of their properties. They're less dense than other metals, so they'll float in water. They are very reactive, and we're going to watch a video that will demonstrate that. Their reactivity will increase as you go down the group. So in other words, lithium is the least reactive and francium is the most reactive. They form +1 cations, and this is always the case. They will never form another charge. Another word for charge is oxidation state. So if I happen to say that word or you hear that word, it just means what charge they form. And I don't normally use the word always when I teach chemistry, but the alkali metals will always form +1. All right, now the next family I'd like you to know is right next door to the alkali metals. They're called the alkaline earth metals. They are beryllium, magnesium, calcium, strontium, barium, and radium. So this family is less reactive than the alkali metals. They form +2 cations always. Okay, so our alkali metals form +1. Next door, the alkaline earth form +2, and these alkaline earth metals are not nearly as reactive as the alkaline metals. All right, now transition metals. They're this block right in the middle here. So you may want to just kind of label this block here as transition metals. They have properties of the metals. They are hard metallic solids, and they have various positive charges. The transition metals go from group 3 all the way up to 12. So groups 3 through 12 would be what we call the transition metals. Okay, the transition metals can have various positive charges. They can be +1, +2, +3, and we're going to learn how to predict their charges in a unit coming up. All right, again, I have this slide in the wrong place. The alkaline earth metals, they're less reactive than the alkaline metals, and they form those +2 cations. Okay, now we're going to head on over to the nonmetal territory, and we're going to talk about a family known as the halogens. Halogen means salt former, and the halogens are going to form a -1 charge when they combine with, say, any of the metals. And when you have a metal and a nonmetal put together, you call that a salt. So like sodium chloride is table salt, Na, a metal, Cl, nonmetal, sodium chloride, it's a salt. So our halogens are a very reactive family on the periodic table. It's a very reactive nonmetal family that consists of fluorine, chlorine, bromine, iodine, and astatine. The four most common ones we're going to talk about are the fluorine, chlorine, bromine, and iodine. They form -1 charged ions when they combine with the metals. And this family, you know how we said families have very similar chemical properties with one another? Well, the physical properties of this family is very different. Chemically, they react the same, but fluorine and chlorine, they're both gases at room temperature. Bromine at room temperature is this amber liquid at room temperature. Remember, the other liquid on the periodic table is mercury, and that's a metal, Hg. Bromine at room temperature is a liquid, and it's the non-metal liquid. Iodine is a solid at room temperature. And all of these, fluorine, chlorine, bromine, and iodine, are what we call diatomic. So we wouldn't find fluorine when it's by itself. It's not just F, it is F2. And chlorine would be Cl2. Bromine would be Br2. We're going to talk about diatomics again in another unit. All right, the next family that I'd like you to know are the noble gases. They are helium, neon, argon, krypton, xenon, and radon. They are very unreactive, and what we mean by that is they don't combine with anything else. The reason they don't is they're already stable. Another word for saying unreactive in chemistry is inert. All right, now we have rare earth elements, and they're known as the lanthanides and the actinides, and they are at the bottom of the periodic table. They're the bottom two rows that just seem like a whole separate entity from the main block of the periodic table. So they start with element 57 and they go to element 89. That is part of the rare earth elements. They're silver or silvery grayish metals. All right, so what I want you to do on your periodic table is the top row is called the lanthanides and the bottom row is called the actinides. We're going to see in class, we're going to look at an expanded periodic table. This block can also be inserted into our transition metals, but what happens is it makes the periodic table just really, really wide. And so they've just decided to condense the periodic table that they would just slip these down here at the bottom, and we're going to show you in class the expanded periodic table. Some people call this the inner transition metals. Okay, let's just talk very briefly about the lanthanides. They used to think they were really rare, but they're really not. They formed during the fission of uranium and plutonium. And when we get to the nuclear chemistry unit, we're going to talk about fission. It's the splitting of the nuclei, and you make a lot of energy. That's where our nuclear power plants get their energy from. The lanthanides are reactive. They are metal, and they're silvery white, but they'll tarnish really quickly when exposed to the air. And I went through and didn't get to show that last slide, but the actinides, they are below the lanthanides, so it's the bottom row on the periodic table, and every element in that period is radioactive. All right, so I hope you know a little bit about the families on the periodic table. The other groups or families, we're just going to refer to them by their number at the top of the column. We're not going to learn their names. All right. Have a good night.